Alright, should be good to go there. Start countdown. Alright, I think we're good to go. Cool, how is everybody today? Cool. Awesome.
Got my P85 in a jar file finally.
Excellent.
I need to start P85.
I would say yes.
Probably just do it all today.
Okay.
Most of I think one of the biggest challenges I had for P85 was trying to have the making a server and client pair and how they communicate or send information.
Mm-hmm.
Like because the example you showed us about how you using server socket and socket as a way of communicating with another.
Mm-hmm.
But the output seems like it just kind of goes to that. It's like a standard out kind of output when you send information one to another, but that's gonna be different for P85, where the information sent is sent to another client. But my question is, how do I retrieve the data that's sent from the server or sent from the client?
So when you create your socket or your server socket pair, you open up the scanner and the print writer, right? All that stuff. And then one side says, socket.println, right? Or socket.printWriter.println. That println statement. So let's. Here's a server. Here's the client. So socket equals, create a constructor for this, and on the server side we have socket equals, accept. So the way it starts up depends whether you're the client or the server, but once you've got a socket, it's exactly the same on both sides. So you do, print writer PW, and you do scanner SC, and the same thing over here. Well, let me change the names of these. Let's say print writer. Let's call this to other, and let's make a scanner, which we call from other. So this is a scanner we can use to read information from the other player. This is a print writer we can use to send information to the other player. And the same thing will happen on the server side. So we'll have a to other, and we'll have a from other. And I'd avoid calling this, to server or from server, because, unless you want to write two sets of code, right? But your code is really the same whether you're the client or the server. Your code is identical other than creating this initial socket, right? On the server side, you create a socket by making a server socket, accepting a connection, and then remembering what accept returns. On the client side, you construct a socket with the address of the server and the port number. But once each side has a client, it's the same code, whichever side you're on. So it's really just, something for sending to the other player and something for reading from the other player. And so at this point, the setup is the following. If one side says, to other dot println, right, and also does the flush. If something on the other side is in the middle of a, from other dot next line, right, this call will block until the other side prints something into its to other. Whatever gets printed into here, right, that's feeding into this side of the socket. It goes across the network. It's available on this side, which is this side's from other. And when you say, you know, from other.next line, it will read whatever was printed in from this side. And so you can think of this as a file if you like. Imagine a well-behaved file that you can write things into by saying print line. You can read things from by saying, you know, scanner.next line. And if there's nothing in the file to read, this will just wait until something prints something into that file. That's basically what the socket setup is doing, except instead of using a file on the hard drive, it uses some magic that's called, you know, a network connection. So you read from by reading from that scanner, and the thing that you read is whatever was printed into the print writer on this end of the connection.
Okay, that makes more sense. I was like wondering how to retrieve information. I mean, even though you went over it in class earlier, but I don't know if it was different for when you print it into a different output stream or input stream.
So yeah, so I mean it's the same thing as if you're doing file I/O. It could be the same thing as if you just printed to standard out, and over here you just typed in whatever you saw on your display, right? Different mechanisms, but the goal is, you know, for example, when the person clicks the mouse here, you have to tell the other player. So you print a message saying, you know, coordinates space x space y. And over here, you're constantly trying to read from your scanner, and it doesn't read anything until those coordinates get printed in. But as soon as those get printed and flushed, this returns and it says, hey, I just saw a message. It said C space 100 space 250. And so your code over here says, oh, I guess the other person clicked their mouse at 100, 250, and you do whatever you're supposed to do, what we've been calling, you know, process click maybe, to go ahead and respond to that click.
And also, last question. Does print writer and scanner have to have the same name for both the server and the client, or
Nope.
is that just your design choice?
Totally up to you.
But yeah, so putting it into a server and constructing the server with those print writers and scanners, and as well as for the client, is the way you communicate back and forth. So.
Yeah. So it doesn't matter what their names are, right? The way they're connected is because this was originally you had a server socket, and then the other player, the client, said, hey, I want to construct a socket which connects to a server socket at this machine's IP address and at the port number 1234. And on the server side, if you tried to accept from that server socket, this will block until somebody tries to connect to that socket. And once that connection is initiated by the client, accept returns, and it gives you a socket. And it's these sockets that are connected through the network now. And like I say, once you've done that, this side has a socket, this side has a socket, everything else can be identical, right? The only difference after that is the server is player 1, the client is player 2. But as far as what they do, as far as this net thread that reads from the socket and calls your mouse click code, and the mouse handler that sends coordinate pairs through the socket and so on, that's identical on both sides. And so you don't need two entirely, you know, distinct sets of code, one for client, one for server. You just need to do something different when you initialize the setup, which is, you know, when you say the start button or you say the connect button, that's how you're initiating this connection, and then it's going to be the same after that. All right, yeah, other questions? And again, if you're thinking about the messaging and how the messaging works and how you keep the two games in sync and so on, just imagine playing this game with a friend using PA4 and a telephone. So you both run, PA4, you both started at the same time, and if you're going to be the server, right, you both understand that you're the server and I'm the client, and so I'm going to wait for you to go first, and you're going to decide where you want to draw a line. You're going to click your mouse, and then you're going to tell me on the phone, okay, here's the XY coordinates I clicked at. I'm going to move my mouse there and click my mouse. And now our games are in sync, right? Because we both see the same line drawn. Both of our screens are saying it's player 2's turn. Both of our screens are saying the score is 0-0. But we know that it's my turn now, so you're not going to click your mouse. I'm going to decide where I want to draw a line. I'm going to click my mouse there, and I'm going to tell you, okay, I just clicked at these XY coordinates. Now you take your mouse and you click at the same position, and our games are in sync again. We both see the line that I just drew. Both of our games say it's player 1's turn, the score is 0-0. And now you click a box that click a line that completes a box, and you see a box drawn on your screen, and it's got your initial in it, and it says it's still your turn. Well, you tell me, okay, I just clicked the mouse at this XY coordinate. I'm going to move my mouse to that location, click the button, and it's going to draw that line. It's going to complete a box. It's going to put your initial in it because it knows it's your turn, and it's going to say it's still your turn. So simply by, telling the other person, okay, here's where I clicked my mouse, the two games stay in sync automatically. We don't have to share scores, boxes, lines, games over, anything like that. We just have to share XY positions for each click. And your PA4 code will do the right thing. If it completes a box, it will remain the other player's turn. If it doesn't, it will switch turns. If it's an illegal move, it will ignore the click and it will remain your turn. But if you get an illegal move, just don't send the XY coordinates. That's easier.
Great question.
Mm-hmm.
So, is there a reason why we need to have a net thread? I mean, it sounds like a really weird question to ask, but I was like wondering, because after all we explained, why do we use net thread?
No, it's an excellent question. We use NetThread because we need to be able to do this business of hanging out on the phone waiting for the other person to tell us where they clicked the mouse. Right? So I make my move. My mouse handler says, okay, you just clicked here, it does its thing. What are we going to do after that? Really, at the end of handling our mouse click, we need to return from the mouse event code. Right? And so if we return, nothing is going to happen until we click the mouse again. But something needs to happen before we click the mouse again. We need to get this message from the other playing saying, hey, I just clicked my mouse, here's the XY coordinates. And there's nothing in PA4 that will let us do that. We could try to write a while loop that says, while we haven't gotten a message yet, let's hang out here and keep checking to see if there's a message. But that would have to go inside the mouse handler, and we don't want to hang out in the mouse handler. Right? That's an interrupt routine. If we hang out there, our window will get wonky. It'll look like it's frozen and so on. So where are we going to have something that's listening on the phone, waiting for you to tell me where you clicked the mouse? That's what the NetThread does. It's a separate process whose job is just to wait for that click information to come in from the socket. And if we, call, next line on the scanner associated with the socket, this call blocks. And we sit inside here until a message comes in. If we do that in the mouse handling code, then we're stuck inside an event handler. And if while we're stuck there I try to, resize my window or something, it's going to look weird, right? It's breaking the GUI by saying, hey, this is a 5-minute mouse event that we're processing, right? We can't do that. When we get a mouse click, we got to go in, respond to the click, and return, so that everything else in the swing system can continue doing its thing, whether that's, you know, resizing the window, displaying things that were covered and now uncovered, or whatever. So this separate thread, this net thread, is just a mechanism to let us say, hey, you know, while we're playing the game and clicking the mouse and waiting for mouse clicks, I want you to hang out there on the side and just monitor this network connection. And anytime you get a message, you know, take care of it. Does that make sense? Or more sense?
Yeah, it does.
Okay.
It does make me up another question, if you don't mind.
Sure.
So for net thread, it's going to be inside like in the while loop. The while loop's going to run forever. I think you mentioned about that.
Yeah.
So while is that could be like going to the while loop the entire game, like no matter whose player it is, or is there something like I have to add it to the net thread class to get out of that class or something like that? Kind of like an interrupt.
So net thread, we're going to have a run method, public void. This is what gets called when we say start, and this can just say, you know, while from other dot has next line. Read line process. And as long as that socket connection is open, we'll sit inside here. When a message comes in through the socket ending with a new line, we'll return from here with true. We'll call, you know, from other.next line to read the line. We'll use split or something to parse it into XY coordinates. We'll call our mouse click handler with those XY coordinates. We'll go back and we'll wait for another line. And we'll hang out in here forever. Eventually, if that socket connection closes, this will return false. We know that the connection has gone away, and we can just, you know, return from our run method, and that's when the thread will die. So yeah, the whole thing this run method does is it just sits in this infinite loop and just reads a line, processes it, and keeps doing that.
Sorry, what's that while loop say? It says
from other.hasNextLine.
Okay, and from other is...
From other was this thing we constructed from the scanner on the socket on either side.
It's on the server side, not the client side?
It's going to be on both sides.
Both sides.
Yeah, because the server needs to listen to the client needs to listen to the server.
So I'm assuming naming does matter, because otherwise it would just look for a whoever. It's going to be hard to determine whose turn it is unless you have some kind of like flip switch.
So if you write your code correctly, you're never going to send a message to the other player unless it's your turn. So when do you send a message to the player? You send it in response to the mouse click. So here's our other piece of PA5. When the mouse is clicked, if it's not your turn, just return. Nothing's going to happen. Right? If we get past here, it is your turn. So, you know, get XY. Process this locally. And then send XY to the other player. And return. That's your whole mouse code in a nutshell, with, you know, most of the heavy lifting happening in this process locally business. But, you know, if it's not your turn and the person who clicked the mouse, just ignore it, just return or print up a message or something like that. But in particular, we're not going to send those coordinates to the other player. The only time we're going to send coordinates through the socket is if the mouse gets clicked, it is your turn, you've read the XY, you've processed it locally, you send those. So the only time that we're going to come out of this is when the other player took a valid turn, right? In which case we read the position where they clicked, we process it, and then we go back and we wait. And we're not going to come out of this again until it's the other player's turn again, which is not going to happen until they get a message from the other player saying, okay, the other player's taken their turn.
I think I was asking, like, if you were to rename it from, like, from server or to server, from client to client, what would you put inside the net thread for the while condition?
Well, in that case, I'd have to have a couple of while conditions. I'd have to say, if I'm the client, then let's read from the server. If I'm the server, then let's do, while from client has next line. And I'd basically have two sets of code here. And I'd have two sets of code here. If I was the client, this would be, to server.println. If I was the server, this would be to client.println. And you're going to end up basically writing your code twice. But this is a point where we can think, instead of client server, just think of other. Right? This is reading from the other player. This is sending to the other player.
Okay.
And what does to other or from other mean? Well, if I'm the client, then I constructed, to other to, be the print writer associated with my socket that I created with a constructor that named the IP address of the server, and so on and so forth, right? That's that initialization when you hit the start or the connect button. But then after that, it's just, here's my socket connected to the other player. Here's a print writer on the socket. If I print into this, it goes to the other player. Here's a scanner I created from that socket. If I read from that, I read from the other player. And it doesn't matter who I am. My net thread is always going to read a line from the other player, and my mouse click is always going to send XY coordinates to the other player. So you can simplify your code if you sort of don't worry about, are you the client or the server, once the game is rolling. Just think about, mouse click, that's my actual physical mouse click. This is, sending that information through a socket.
I have to do one thing extra. I still have to send mouse clicks or messages, even when it wasn't my turn, so that I could send a quick message properly.
Ah, yeah. So quitting can be tricky. But if you hit the quit button and you send the queue message, right, the other player's net thread should pick this up, and when it reads the line and it's ready to process, check to see if it's a queue. And if it is, you want to go ahead and quit, but maybe you want to set a flag somewhere, or maybe you want to do a system.exit0, which just shuts everything down, or something. That can be a little tricky to get just right, but see what you can do.
Well, I had it set up, but stylistically what I did is when player 1 quits the game, it closes their window and sends a message to player 2. Player 2 gets a message saying player 1 disconnected, but doesn't close their window immediately. Is that okay?
Sure, that's fine. When does it close the window?
Well, it doesn't close the window until the other player also presses quit or presses the X button.
But it gives you a message saying that they quit? Does it give...
The quit button will still work, it's just it doesn't immediately close because that's a little jarring.
Does it give you a message saying player 1 quit?
Yeah, player
okay.
1 quit the game. It'll close their window, but it won't close player 2's window. It'll just show a message saying player 1 quit, and it will disable the game, but it won't close the window randomly. That'd be kind of jarring, I think.
Yeah, that's fine. That's fine. Yeah, otherwise your window is just like poof. So yeah, either way, I'm totally fine with that.
Could you say one more time what from other dot has next line is when it's true?
When it's true, it means that the other player must have done a print line into the socket, so they sent you XY coordinates. So what do you do when you get a line? Read the line. So, string line equals from other dot next line. And if that line is something like, CXY, parse it. So use a split statement or something to make an array. Use integer.parseInt to get these. Now you've got the integer xy coordinates where the other player clicked the mouse. Go ahead and call the code that runs when your mouse gets clicked, right? This process locally, right? Go ahead and process that xy click just like you did in PA4. So this was yeah. And you may want to do something like you know, change the turn flag to indicate that the other player has taken their turn, and so now it's your turn again. So that you know that if the person clicks the mouse over here, it's a legal thing to do, and you can go ahead and do this stuff. And again, you know, my standing suggestion since 2.24, creep up on the solution. Start off, you know, don't worry about exchanging names. Just don't worry about the quit button. Just use one type of message, just XY coordinates. Assume everybody's playing correctly. So people will take turns. Don't worry about the possibility of clicking out of order. And just focus on, you know, when the person clicks the mouse, can I do what I'm supposed to do locally? Can I send that XY to the other player, and will that other player's thread pick up that XY and do what it's supposed to do? And that's, you know, 90% of the game right there. And it's ignoring the names, it's ignoring the quit button, it's ignoring monitoring whose turn it is. Right, but it lets you get this new piece, the threads and the network connection. Those are the new pieces for PA5. It lets you work with those very quickly without trying to pile on all those other details. And so this is, you know, classic problem solving, right? Break it down into sub-problems and solve those first. Another piece of that is, you know, change the problem, make the problem simpler, solve the simpler problem, and then work up to the more complex problem. And that's math, physics, programming, anything, right?
I'm gonna ask this, even though someone's probably already asked.
Okay.
Does each player's client do you have to create a new server for both players?
So we create one server and one client. So the players themselves, one of them is going to be the client. So here's player 1, here's player 2. Player 1 is going to be the server. Player 2 is going to be the client. And so each side has exactly, you know, one socket. Either a socket on the server side or a socket on the client side. And so player 1, you know, creates a server socket. And says accept. And that will return a socket. Player 2 is going to say something like sock equals new socket. With the name of the machine they want to connect to and the port number. So this server runs first. They hit the start button, it creates a server socket, it calls accept, and it sits here in accept waiting. Player 2, after player 1 has hit the start button, player 2 hits the connect button that constructs this socket, which tries to find the server socket. If this is sitting here in accept, this will successfully connect to the server. Accept will return with a socket over here. Your constructor will return with a socket over here. And now you've got exactly the same setup on both sides. Player 1 has a socket, which we're calling sock. Player 2 has a socket, which we're also calling sock. And these are connected through the network. And now you can go ahead, construct the print writer, construct the scanner, and start doing your communication. And from that point on, the notion of who is the server, who is the client really doesn't matter. Right? The only difference it makes for PA5 is whoever was the server, their player 1, and so they're going to go first. But from the network point of view, it's just a pair of sockets now connected. And the fact that this was the client and this was the server, completely irrelevant to us.
Okay. Another question.
Yeah.
If both players choose the server button, what do we do?
Send a little high voltage charge through the keyboard and put up a message box and say, stop that. No. So if both people want to be the server,
What's the question? Oh,
that's fine, but they won't be able to connect to each other. So if you hit the server button and say start, and I hit the server button and say start, we're both servers, we're waiting for clients to connect to us. And that's perfectly fine, but we're not able to connect to each other that way. But, you know, somebody else could connect to your game, another person could connect to my game, and we could play. But to play against each other, one of us has to be server, one of us has to be client. And there's really nothing you can do to check for that, right? If the person runs your PA5 and says, I want to be a server, and hits the start button, you have no way of knowing if somebody out there in the universe is running PA5 and also said they want to be the server.
whacked as fuck.
It's not your concern whether that's the case, right? Your only concern is when somebody says they're the client, they should connect to you. If someone else wants to be a server, hey, you know, that's their life. That's totally legitimate. They're just not playing the game with you right now. Yeah, I think your mic cut out.
Oh. You guys have been listening to me play Clash Royale.
Oh boy.
I do have a question though about creating a socket.
Yeah.
So, from what I remember, you create a socket by putting in the name of the machine, right?
Mm-hmm.
Or you put in an IP address
Mhm.
or something like that.
Yeah.
Because in the GUI there is a box you put in a user interface, or put in the put in like the little box that you put in like who you want to connect to, basically.
Mhm. Yeah.
Do we have to parse it into like an integer?
No.
Assuming that somebody put in like a number like 192, 168, so on.
Yeah, you can just take it as a string.
Does the string actually work when you put it into the socket, even though it's a number?
Yeah, isn't that cool?
It is cool.
So I can make this one the server, and I can start, and I can do localhost, or I can do 127.0.0.1, and it'll still connect. So this is being passed to the constructor as a quoted string. I'm just doing a get text on this text box and passing whatever the string is. And if it's a string containing, you know, something dot something, it will interpret that as an IP address. And if it's a name, it will use some kind of name resolution to change it into an IP address. So yeah, we can be pretty lazy on our end. All right, cool. All really good questions. So I got office hours tomorrow, office hours Friday morning. If you haven't used slip days, you can turn this in until Tuesday morning at 8. I think that's 4 slip days. All right, cool. Well, let's go back to playing with Eclipse and continuing to build this notion of networking in Java. I'm going to do this in Eclipse because we're going to use lots of classes, and I don't want to have to import them. And sometimes I'm going to rely on the GUI to help me with these classes. So the first class I want to talk about is URL. And URL is a cool class. We can construct by simply specifying, guess what, a URL, right? Or, you know, a protocol in a URL. URLs are, you know, mostly we think HTTP or HTTPS, Hypertext Transfer Protocol. But there's other protocols we can use. We could say, you know, mail to, or we could say FTP to do file transfer. And these are all, you know, contained under the umbrella of Universal Resource Locators, URLs. But we can construct with just a string specifying, you know, the thing that we want to go after on the web. And the main piece of interest to us right now is we can open an input stream associated with a URL. So we can call the openStream method, and that will give us an input stream. And among other things, input streams, remember, are things we can use when we construct a scanner. And so I'm going to play with one particular web page, a favorite that everybody should know, apod.nasa.gov. So that's the astronomy picture of the day. And it's a great site. It's relatively harmless in terms of, you know, being pummeled with psychologically damaging headlines. So here's, you know, a picture of meteors over a telescope, which is pretty cool. So every day they post up a different picture, and it's a lot of times it's pictures from the Space Telescope, or it's pictures that somebody took with a long exposure or a lucky timing or things like that, and then some kind of explanation about it, and a little preview of what tomorrow's picture is going to be. And if you go to Discover the Cosmos, you can get back over the last few pictures. So yesterday's was a Falcon rocket taking off in front of the sun, and that's just like a cool picture, I thought, and a description of it and so on. So this is a fun site, digitized lunar eclipse and the Milky Way's black hole and stuff like that. So this is a fun site, and it's a nice one to pick on for playing with web stuff, because, you know, it's HTTPS, it's secure, but it's pretty straightforward protocol. And if you haven't messed around with web pages a lot, right? If you hit a Control-U, this will show you the source code for the web page. And so this is just an HTML page. And HTML is a markup language. So there's tags inside angle brackets. So this whole file is an HTML file. And it ends with /HTML. That's the end of that tag. So everything between here and the beginning is part of an HTML file. And there's a header which runs from here down to here. And there's a title which runs from here to here. And the title is Astronomy Picture of the Day. So if you've done web design, you know all this. But if you haven't, right, this is, you know, if I made this file myself and I changed this, then the title would come out with something different. And because I said angle bracket title, it's bold-faced and it's got a certain font and so on. And a web page can be that simple, right? So here's a center, astronomy picture of the day. H1 is the type of text. That's a first level header. and then a paragraph, and then something that says discover the cosmos. And this is inside a hyperlink reference. So this is saying, hey, I want a clickable link which says discover the cosmos, and if somebody clicks, I want to go to this page, archivepics.html. Well, that's where this came from. Right? It goes to archivepics.html, and it's underlined because it's a hyperlink. And then there's a paragraph break, and there's the date, and then there's a line break and another link, and so on and so forth. So this is you know, where web pages come from. So what we want to do is we want to try to access this from Java. And we're going to do that using this URL class. And the main thing we're going to do first is we're going to open a URL to that page, and then we're going to construct an input stream, or get an input stream using this OpenStream method, and use that to construct a scanner. Alright, so I'm going to play from inside Eclipse, just because. Alright, so let's make a new project. And let's call this Page Getter, because that's a horrible name. So I'll do a right-click, new, other. I'll make a J-frame. This is all going to be GUI based. I'll pick a totally random name I've never used before, like main. And let's go ahead and let's just put a button on here. And the idea is when we click this button, I want to read this web page. So I'm going to do an absolute layout, and I'm going to put a J button down here. It's giving me a hard time already. Let's try that again. Okay, there's what I was looking for. All right. The reason I'm doing all of this in the button is because, you know, when you do a swing layout like this, right? We have our main program. It creates a thread which constructs a frame, makes it visible, and then exits. And so I could monkey with the constructor of this frame, but I don't want to do that. So I'm just going to use a button to sort of trigger all of the action. And I'm just going to call this button Go. And I'll double click to come into a set of code that will be run when I click the Go button. Alright, so let's do our business here. So we're going to say construct a URL for the astronomy picture of the day. So I'm going to say URL page equals new URL apod.nasa.gov. And then I'm going to construct a scanner. And I'm going to do this a little more carefully. So I'm going to have to construct my URL inside a try-catch block. And I'm going to have to get the input stream inside a try-catch block. So I'm going to declare my URL object and my scanner outside here, and then I'm going to put all of this in a try-catch block. So I'm going to do page, and I'm going to say OpenStream. And I'll catch an exception. I know I spelled it wrong. All right, let's go ahead and do these imports. So I'll just hover and say import URL. And I'll hover on the scanner and say import scanner. And that will create these imports for me. If you haven't noticed, right, there's code folding in here. And so there's a little plus sign next to line 3. And line 3 actually is a bunch of code from lines 3 through 11. I can expand that by clicking on the plus sign, or I can make it go away. So I know here's my import statements, right? So that's just a IDE thing. All right, so where were we? We construct a page from that URL. We construct a scanner. At this point, we should have scanner should be available for reading from the web page. So let's do our standard scanner loop. And then we'll just close our scanner at the end. And that's the end of our button press code. All right, so this is pretty simple, right? We're going to hit a button. When we hit a button, we'll construct a URL object. We'll construct a scanner from that URL's OpenStream method. And then we'll just do our sort of standard for loop while we have another line available from the scanner. We will read it in, and we'll just print it out to standard out, so it'll come out on our console. Yeah, thanks for the catch on the imports. All right, so let's go ahead and run this. And let's hit the Go button. And we get a bunch of messages. And if I look at these messages, what is it? It's the HTML for that web page. Right? It's all of this stuff that we saw when we hit Control U on here, right? So there's the document type tag, HTML head, there's the title page, and so on and so forth. So from Java, it's really easy to read the contents of a web page. And this is all that a web browser does. When you have a web browser and you put in a page and you hit enter, it basically does this kind of thing. Probably not in Java, it depends what your browser is written in, but it basically makes a connection to a server socket on the destination machine, which in this case, you know, is apod.nasa.gov, and it asks for a page. In this case, astropix.html, and the server basically finds that file, opens it up, or maybe constructs it on the fly, takes the contents and sends it back one line at a time, and this is the stuff that actually gets sent. Now the browser takes all of this and turns it into this. We don't have a browser, we just have a Java program which just, took the information coming back from the server and printed it out line by line. But this is the information that Firefox retrieved, but it rendered it, as a web page. So it put a little title up here, and then it saw the title tag as a header 1 and did that, and here was a hyperlink, so it made it a different color and underlined it, and it knows if I point to that, it should change the cursor, and if I click on it, it should follow that link, and so on. But the essence of this, which is retrieving information from the web server, right? That's really all you need. And if you try to use a page that doesn't exist, like APO, right, we'll get an error, unknown host exception. So it couldn't find, anything with that that URL address. All right, good so far? All right, good place for a 5-minute break. Let's come back at 11:01, and let's turn this program that prints out the HTML, let's turn it into a web browser. So we'll learn about a couple of other Swing components that will let us render this information that we're getting from the web server into an HTML page. And then we can...
Something like an iframe?
Something like that, yeah.
Nice.
Alright, so we'll be back in 5 minutes. We'll make a new web browser. Alrighty. So let's go back to our design tab. And we're going to add a new object to our window. This is going to be an editor pane. And an editor pane, let's go ahead and pull the doc. Alright, so an editor pane is So it allows you to load content in different formats, which can be plain text, or it could be HTML. That's the case we're worried about, or it can be rich text. So if you use like Writer under Windows, that's just a good old rich text format, simple markup language for boldface and things like that. So let's go ahead and come in here and let's create a new, let me find it. Let's just create a JEditorPane. So I'm going to drop this object in here, and I'm going to make it bigger. And it's just called EditorPane. And I'm going to use this in my button press code. So I'm going to move the declaration of it. This is our usual trick. Move the declaration of this up into the beginning of the class so that we can get to it elsewhere. And then down here I'll go ahead and construct it, but I'll leave the declaration up top. Rich text can be fun sometimes. Until nobody supports it anymore, and then it's just sad. So I'm going to get rid of this business that we did here. Let me just comment it out. And let's get rid of this scanner constructor. Alright, so now I'm going to do the following. I'm going to, construct my URL object from the web page I'm after, and I'm going to save that in an object called page. And now I'm going to do one method on my editor pane. I'm going to do EditorPane.setPage. Page. Alright, so that's all I've done. I've gotten rid of all my scanner stuff. I've added one line, which is the setPage method on the EditorPane object. And setPage basically sets the current URL being displayed. So let's go ahead and run this. And let's hit the go button. And guess what? There's our web page. And it's tiny, and we can't really do a whole lot with it. And we can't click on anything. But it's there, right?
They're not able to move up and down.
Not able to move up and down, not able to scroll. If I click anywhere, it seems to change what I'm looking at, but I can't actually click on links. There's something cool down here.
It's like it's zoomed in rather than.
Yeah.
It looks like it.
So it's a pretty unusable page, but we've got something, right? It's interpreting HTML. That's good. All right. Well, with just a little bit more work, so by adding a JScrollPane, we can make this a lot more usable. So I'm going to do a small trick here in Window Builder. I'm going to right-click on this editor pane. I'm going to say surround with. I'm going to say let's surround this with a JScrollPane. And now if I run this and I hit my go button, I've got scroll bars. And so I can scroll down and I can scroll across, and I've got something closer to, you know, an actual web page. Still can't click on stuff, and you know, it's just this tiny little box, which is not really optimal. But you know, clearly we've got the entire page rendered, and we can do some navigation using our scroll bars. I'm actually just holding the Shift and Control button to scroll vertically and horizontally. Alright, so let's keep going. Let's change the size of this. So I've got this frame sitting right now, and it's sitting at, well, I don't know where it is. Let's go see where it's constructed. It's sitting at 163.49. So let me change this to 50/50. So you got to move that up there. Let's put our go button up at the top. Alright, so there we go. So let's make this window resizable. Now we can use a window manager to do this for us, but we don't need to. We can kind of take a Neanderthal approach here and say, hey, you know, let's change the size of this window in some reasonable way. So I'm going to click on my JFrame. I'm going to right click. I'm going to add an event handler, and I'm going to say container, let's see, component resized. And let's just throw a print method in here because we don't know what we're doing. And let's just print out and we can go and we can look at a JFrame and look at the different methods available to it and so on. But there's a method called getWidth, and a method called getHeight. And let's just print out what getWidth and getHeight return. And so, you know, initially it says it's 450 by 300. If I change the size, right, I can change the width, I can change the height, and so on. And so apparently every time that I resize the window, this piece of code gets called. And inside here I can see what the new width and height are by calling getWidth and getHeight. And so let's go ahead and let's change the size of the editor pane. Alright, so I'm going to set the size to be whatever the width and height of our JFrame are. And again, if you look at the EditorPane method, it extends a class that has a setSize method, and setSize takes an XY pair and sets the dimensions accordingly. And so if I run this, oh, nothing happens. Let's try. Let's try changing the size of the scroll pane. All right. So I can run this and I will see more on my web page, but you know, my page is running off the edge of my window here. Why? Because I'm setting the dimensions of this scroll pane to be exactly the same as the J-frame, but my scroll pane starts at 50/50. So let me tweak this a little bit and let me set the width to be the width of the J-frame minus 75, and let me set the height to be the height of the J-frame minus 75. And so now, let me change the height. Well, make that 150. Alright, so now I got a little border around my frame, but as I change the size of the J-frame, this panel changes size accordingly. And so now if I load my page, I got something that's starting to look more like what we would expect from a bona fide web page. It's a little slow, but it'll come up. There we go. And, you know, I can scroll around, and if I make it too skinny, I get a horizontal scroll bar. If it's wide enough, that goes away, and I get a vertical scroll bar. And if I made my picture, my frame tall enough, my vertical scroll bar would go away. But you know, this is starting to look like a reasonable web page, right? But no clickable links. Alright, but what have we done? We've written like, you know, 6 lines of code to get this up and running. So we had to do a constructor for a URL. We had to set a page in the editor pane. And then I you know, just for fun, added something to resize the editor pane based on when the J-frame changes size. And like I say, the role of a window manager is to do that for you. We could use a different window manager, so in my main layout, I could choose something like, you know, a border layout or a grid bag or a box and so on, and I could set it up so that things are automatically resized as the window sizes. But just, you know, kind of demonstration, we can always do this stuff ourselves. I'm going to make this a little bit less of an extreme border so that looks a little more reasonable. Alright, so let's add clickable links. Come back to our design tab. Let's come in here, let's right click, let's add an event handler, and there's a hyperlink category and there's a hyperlink update. And so we can left click on this and we'll come into a set of code, which is a different kind of event handler. And in this case it's an event handler which is called with a hyperlink event. So what do you do when you want to learn what something is doing? Throw in some print statements, right? So let's just put in a print statement saying we've got a hyperlink event and arg0 is equal to, and let's just print out the value of arg0. And then let's run our code. Let's go ahead and load our web page. And now if I move my mouse over this hyperlink, nothing happens. I meant to do that. Alright, so here's the trick, and this is documented, but it still takes a while to find the first time. This page is normally editable, so you have to set the editable flag to false. And we can hardwire that in Window Builder by coming here, going down to editable, unchecking that box. And if our box is not set to be editable, then if we come over a hyperlink, it'll fire an event. So by just moving my mouse over this thing that says Discover the Cosmos, I got an event generated. And when I move my mouse away, I'll generate another event. And if I leave my mouse there and I click it, each time I click, that will generate another event. And so, you know, we're just using the toString method of whatever this hyperlink event is. And the toString method basically spews out all the fields, all the properties of this object. But if we kind of scroll through these and see what's happening, we should see a bit of difference. Perhaps not. All right, so we have to dig deeper into these hyperlink events. So a hyperlink event, get event type and get URL are the two main things we're interested in. So get event type will tell us why we're in this method. And so it returns a type of event, which is an int. Sorry, it's a event type. And then get URL will return a URL, like the thing we constructed originally. So these hyperlink event types, we have three types: activated, entered, and exited. All right, so let's incorporate that. And in our code that says we got an event, so let's do arg0 dot, and let's do this get event type method, and run that. Load up our page. And so when I move my mouse over here, it tells me I got a hyperlink event and the type of event was entered. If I click, it'll tell me the type was activated, and if I move my mouse away, it'll tell me the type of event was exited. So we're just playing with classes. This is what Java programmers do all day. You just play with classes. So in this case, you know, we've got a class which is this URL, this editor pane, right, with the page set to the URL, and there's listeners. We've got a hyperlink event listener set up, and whenever an event occurs, this listener is called and is passed an argument, arg0, and we can use that argument's get event type to see what type of event. So the picture itself is a hyperlink. And so when I enter, right, it tells me that an entered event just occurred, and when I exit, it exited, and if I click, it says activated. All right, so that's one of the two most relevant methods for us. The other is get URL. And so let's add another print method here. Let's just call the get URL method on the argument and print out what that is. And so one more time, load up our page. And now if I move over to Discover the Cosmos, it tells me, hey, the URL is, you know, archivepics.html. That's the page that has, you know, the list of different dates and what the pages were on there. If I come over here, the URL is, and it's a JPEG. It's a JPEG of this meteor shower. And if I come down here on this person's name, it shows me this person's page from Arizona. And if I click on this, if I point to this, right, there's a page for arizona.edu. So we've got the pieces we need to make actually a full-blown browser. So what would be a good next thing to add to this code, maybe? If we wanted to keep digging.
Probably integrate a BitTorrent client.
Definitely.
Just like all the current websites, you could put like a Bitcoin miner. So like, you know, mine Bitcoin in the background, just like
I like
today.
I like the way we're thinking here. This is good entrepreneurial development.
You probably didn't notice, but actually all of the assignments I've ever done for you have those in them.
Do they? Excellent.
Yeah, I made like a solid $3. No.
Cool. My virtual machine thanks you. All right, so let's add something to follow hyperlinks, right? That's the main thing you want to do. Point and click, point and click. So when we get over a hyperlink, we can see, you know, that we entered it. We can see what the URL is. When we click, we'll get an event type of activated, and we can see what the URL is. All we've got to do is change the page we're looking at to, you know, whatever the page was that we were just clicking on, and we should have, you know, a fully functional browser that can follow links. So let's do the following. Did the person click on a link? So if arg0 get event type equals, and these event types, these are statics defined in this hyperlink event class. Let's see. Or in hyperlink.event type. So there's a hyperlink event.event type.activated, and that's a static field that will tell us if that's the type of event that we just had. So we don't have magic numbers, right? We don't say if this is a 1, then it was activated. If it was 2, it was entered. The magic numbers are hidden underneath these static fields. So let me see if I can, I'll just copy and paste. I don't want to stress out my memory this early in the day. Alright, so if arg0.getEventType, that's a method call. If it returns hyperlink eventType.activated, so the user clicked, so URL new page equals arg0.getURL. We don't have to do this. We could do this in one line, but I'm just breaking it out into pieces. All right, so how do we make this URL the page that we're looking at? We can just do this setPage method. So now we can just say EditorPane. Point setPage, new URL, new page. That's got to go in a try-catch block, because if this page isn't available, we'll throw an exception. So, you know, if you haven't discovered this already, right, hover under this. It says, hey, you could surround this with a try-catch block. Just click that. It sets it up for you. And that should be all we need, unless I'm missing something. So we've added some debug statements and some print statements, but really, all we had to do was add, you know, these two statements. If the event type is activated, let's set new page equal to this, and then call the setPage method with that new URL. So run this. Make our window big. Load our initial web page. Click on Discover the Cosmos. This might take it a while. There we go, and there's our new page. We want to see this picture, we can come down here, click on it, and there's another picture. That's a cool picture. Alright, we got a bit of a browser here. Oh, that was sadness. So we obviously have not incorporated JavaScript into this browser. But, you know, we can follow links anyway. We're going back into the 90s now. We're going to get to the 80s soon. All right, questions so far? There's 2 points to do. There's 3 points to doing this. 1, it's fun, right? 2, it's you know, learning some new classes, URL class, EditorPanes, ScrollPanes, right? But 3, and possibly most important, it's another instance of this idea of, you know, what is a class? Well, you know, there's a class called URL, and we constructed an object of this type by doing this. But this object is a powerhouse, right? It's got, you know, all of the stuff inside for doing a socketed connection, making a connection to a particular port on a particular machine and requesting pages and so on and so forth. All of that is encapsulated inside this one object. And an EditorPane is another object. It's an object of type, you know, JEditorPane. And it has a setPage method, and if I pass it this URL object, we get this whole visual display with hyperlinks and so on. And we can you know, say an add hyperlink listener method on that EditorPane and specify code that should be called when you interact with a link. And so, you know, there's all this stuff going on. There's all these bits going back and forth, socketed connections and so on and so forth. We're ignoring all of that. We're up here. And we're saying, hey, show this page. Hey, if you click on a link, do this thing and load a new page, right? And our code is pretty trivial, right? Get an event if it's activated, get the URL they clicked on, set the page to show that. And so we can get something like this where we can show a page with graphics and text and so on, and we can, you know, click on links and follow them and so on and so forth. And we can get spam and all kinds of stuff. Alright, how would we add a back button? How would we make it so we can go back, so when we click to a page that shows up and is kind of uninteresting, we can go back to where we were? What would that involve?
Okay, so the first thing that comes to my mind is make a linked list for some dumb reason.
Yeah.
I'm just going back.
Totally. So we could, you know, have a previous page object, and every time we change page, we could set previous page equal to the current page, and then when you hit the back button, it would just load previous page. But that only works once, right? What we really want is the ability to remember a bunch of previous pages, and we want this memory to be, you know, such that if you view this page and this page and this page and this page, and then you hit the back button, you go back to this, and then you go back to this, and then you go back to this. That's a queue. Sorry, that's a stack. The last page that you were on is the first page you should go back to. And how do we implement a stack? Linked list. It's a great way to do it. So now we're totally playing without a safety net because I didn't have time to try this last night. But let's proceed confidently. And let's make a history of our web pages. So this is going to be a linked list of URLs. So we'll remember pages we visited. We'll have to import linked list. And I'm going to add a back button. So we'll move go over here. And then let's put another J button. And we'll call that back.
I've been thinking about it for a while. This would be very difficult or very hard to do at AC.
Yes, definitely. The networked connections themselves are pretty frightful. And then trying to do the graphics. I mean, if you like OpenGL, you can do that. Or if you have another package. But in general, yeah, this would be really, really difficult in C. Not bad at all in Python, because Python is modern, right? And pretty painless in Java. All right, so let's go back to our hyperlink update. And if we're going to go to a new page, we're going to make a new page here, right? Let's save our current page in our linked list. And so let's refresh our minds on linked list, which means let me refresh my memory on linked list. So add will add to the end and remove, well, we can just do push and pop. So we can push onto the stack, we can pop from the stack. So we'll just do push pop. So we've got a linked list called history. All right, we're going to start this whole process with the go button. So we're going to get a page which is a new URL, and let's go ahead and let's push that onto our history page. And then when we follow a hyperlink and we get a new page.
Question?
Yeah.
What does the linked list contain? Is it a linked list of strings?
It's a link. I made it a linked list of URLs, so it will be a URL that we can just pass to this setPage method. But you know, we might want to make it a thing of history of strings, so that we could, you know, look at them as humans. But URL is sort of like the biggest wrapper, and if we have the URL object, we can get the string out of that. We can actually just call the toString method, and I think it converts it to the string we would expect. So we can add another button which says show history, and use that to print out what's currently in our linked list. So when we follow a hyperlink, we get this new page that we're going to. We set that to be the current page, and let's add that to our history. So let's do history.push new page. It even knows what I want to push, right? How does it know that? Because the only URL object I have access to in this method is new page. But, you know, I'm going to type it anyway. So that should push the new page on there. And so we've got a stack, and the top of the stack should always be the page that we're looking at. And so let's add one more button here. Let's add a button like show history. So for I equals 0, now let's do history.getI. I broke my let me do this a little more carefully.
I have a question.
Yeah.
What is it then when you go to websites and like they do something sketchy and then like, well not really, then like you try to go back, but like your history is just full of this single website. It's like the most annoying thing ever. You can't just back out of it.
I think it's that your current page you're on is accessing other things on that page, and I think if you could go back far enough, you'd get back to the pages before that. But it may be that the way that page is resolving the content is hitting other things on that same page. But
See, the problem is when you go back, it must hit more of those because you can just endlessly go back and it just keeps.
yeah, I know what you're talking about now. So when you hit the back arrow, it just leaves you on that page. And sometimes if you hit the back arrow really fast, it takes you back to another level. But yeah, I think it's going back one page and very quickly, re-rendering that page and following a link to something else. And so you're kind of stuck in that loop. And you could rectify that, right? You could say go back to the previous page with a different domain, and you could filter out the most recent things in your history that had the same initial part of the domain, and skip over those and go back to the thing that's actually new.
Yeah, I got a question.
Yeah.
Or almost like it's mostly a statement, but but when you keep popping from a stack and there's nothing to stack, does it throw the exception?
Yeah, so if we keep popping and the stack is empty, we're going to get an exception. And we'll have to catch for that.
So you probably should put the pop into a try-catch block, or is that...
No, I wouldn't use a try-catch for that. I would just check when you're ready to pop, make sure the stack's not empty. And if it is, then say, you can't go back any further. Or better yet, just disable the back button if your stack is empty, which is what browsers tend to do.
Okay, that makes sense.
So at some point, if I was going to keep using this version of Eclipse, I would turn off autocomplete, because autocomplete does not work well when you ignore it. So let's do this one more time. Date format symbols. All right. So let's try this, and then let's add our back button. So let's go ahead and load our URL. Let's follow some links. Oh, we're throwing exceptions. So what did I forget to do?
I don't know. What's the error say?
Oh, you know, null pointer exception.
Oh,
Yeah.
I love that one.
Yeah.
Oh, shoot.
So if you don't know it, right, click through to see what's line 118. I'm trying to push a page onto history, and I made...
Doesn't exist.
History doesn't exist, right? I declared it, but I did not construct it. So where should I construct it? Well, I could construct it right here, but I'm going to go ahead and construct it inside the constructor for the JFrame. So for no particular reason. So initialize the history list. I'm no longer fixing typos because we're down to like 25 minutes. So we'll do that. We'll construct our new linked list of URLs. We'll run this, make the page big, load the page. Click on Discover the Cosmos. Click on this thing. Click on the 2 to 3 meter telescope, and now if we show the history, right, there's the last pages that we looked at. We started here, we went to the archive pics, we went to that picture, we went to Arizona, and then we went to the telescope. So the back button, we just need to pull off the pages from our linked list and load those accordingly. So let's look at our linked list. So we can retrieve and remove the head of the list. Pop. So what's a little weird with our list is we got page 1, we got page 2, we got page 3. The top of the stack is always the page that we're looking at. And so when we say back, we want to pop off this page, and then we want to display what's currently at the top of the stack. So let's make our back button. And we'll fix some typos. Go to the previous page in the stack. So history.pop. This is dangerous because if the stack's empty, we'll throw an exception, but we'll fix that later. So I want to go load the current top of the stack into the editor pane. So how do we find the thing that's currently at the top of the stack? So this is 0, this is 1, this is 2, this is 3. And size in this case would be equal to 4. So the index of the last thing on the stack will be the size of the stack minus 1. This is like, you know, doing array indexing because a linked list can also be treated like an array. So so let's do this.
If you do like an array, does that mean that the very first element in the linked list is always at index 0?
Correct.
Okay.
Yeah, if we use this get method that says get the element of this index, yeah, first element will be index 0. So URL new page equals history.get history.size minus 1. And then we can just say EditorPane.setPage new page. And this has to go in a try catch. And we should be all set. So the back button is going to pop off the top of the stack. That's the page we're currently looking at. And then it will find the last page on the linked list and use that to set the content of our current editor pane. And that should basically take us back to the last page. So go ahead, there's our main page. Here's our Discover the Cosmos. And then if we hit the back button, that should take us back to where we were. So we can discover the cosmos, we can go to Titan Moon over Saturn, we can look at JPL Caltech, JPL rocks, by the way. If you're not familiar with Jet Propulsion Laboratory, they're like the coolest place.
Looks like that has a JavaScript.
Yeah, so this is only displaying HTML tags, so anything with JavaScript or anything fancier is not going to show up correctly. So we can look at the history, right? This is our current page. That was previous, that was previous, that was previous. If we use the back button, we can go back to the moon rising over Saturn. Oh no, that wasn't the right page. Well, we did something wrong. I did something wrong.
The result of history.pop, I don't think.
Yeah.
Yeah, see, you didn't. Yeah, shouldn't you just get history.pop instead of doing the history.get, history.size -1?
So I think history.pop is just going to be our current page, because I'm pushing the page onto onto it when I go onto that page, so I want to get rid of that. But I'm violating the notion of an abstract data type. I'm using a stack, but I'm also assuming that the new elements are at the end of the array, and that's not really what I want. So I really just need get first. So, you know, I should have a better understanding of my linked lists, and I should either be treating this as a stack and using something which says, you know, peek at the top of the stack, but don't remove it. And there may be something like that. Or I should be treating it like an array and just doing, you know, a last in, first out manually. Or something like that. I'm being sloppy with this. And this, unless push is guaranteed to always insert at the beginning of the list, which it may be, but it's not, right? So I should be doing like put and get, or use the index, or something like that. But it's Wednesday, which is Friday, so we can be a little sloppy here. So we'll go to Titan, and we'll go to JPL. Oh, I went to the wrong page. Okay, we'll go to Chinese astronomers. And then if we go, oh, that's cool. Nice. All right, so now if I go back, I'll go back to the Chinese astronomy page. If I go back again, I'll go to that picture. Slowly loading. And then if I go back once more, I'll go to the list of pictures, and if I go back once more, I'm back at the original page. And then the only other issue here is, you know, if I try to go back again from here, my stack is empty, and so I'm trying to access the beginning of the stack when there is nothing there. And that's not horrible. Let's just be a little careful when we hit the back button instead of doing the pop. If history size is equal to 1, there's only one page in the history, and so let's just return. Maybe we'll print a message. Cantor. So load your page. Discover the cosmos, go back to your first page, and then if I try to go back once more, I'll just get a message saying I can't go back anymore, nothing gets popped, and so on. And then you can go forward, and you can go back, and so on and so forth. So there's you know, the rudiments of a web browser. And it's taken us, you know, since break, so 50 minutes to put this together. But the actual amount of code is, you know, probably less than 10 lines, right? A lot of declarations and a lot of places where we broke things into pieces, right? But the actual amount of code that we had to write was minimal. Because, you know, these are objects that come from these classes that have all of these methods and all of these fields inside them and are built on top of other classes that have, you know, methods and fields inside them. And so loading a page is really just a matter of calling the setPage method. And storing a history of these is just a matter of constructing a linked list and calling the push method to push a page onto that list. And if you think about doing this, you know, in 222, where we had to write a bunch of code to implement a linked list, and we'd have to write, you know, all the stuff we never went over for pulling down pages from a website and displaying them and so on and so forth, right? This is why, you know, so much stuff is object-oriented now. Because, you know, we're not writing, you know, hello worlds. We're constructing code that does, you know, sometimes these massive things. So vision processing. So one of the people in the class was working with a package called OpenCV, right, which is an open access computer vision system, and in talking to them about it, I kind of got sucked in on my own experiments with playing around with this stuff. OpenCV is a package of Python classes. It works in different languages that encapsulate all of the gory details about, you know, the low-level aspects of vision processing, filtering and edge detection and you know, shape recognition and so on and so forth. And with a few lines of code, you can get some initial demos up and running that are pretty impressive. And it lets you concentrate on what is it I want to do. Okay, there's a class that will let me get a web page. Here's a class that will let me make a linked list. What I want to do is I want to make, you know, a window that will get a web page, and if I follow a link, display the new page. And then if I hit the back button, it will go back to a previous page. Or maybe, you know, I want a back button that, you know, goes back to a previous page that was coming from a different site. And so I could have a super back button, you know. I can clear my history. Well, what does that do? It just calls, you know, history.clear. And it gets rid of all of those history links. I can show my history. I could just, you know, make a loop and print each thing that's in my history. I could save my history. And I would just, you know, open a file, make a print writer on it, and then when I iterate across my linked list, I would just go ahead, instead of writing that to system out, I'd write it into the print writer that went into a file, and now I can save my history into a file.
Great question.
Yeah.
So can classes be written in a different language and be called by a different language? And the reason I'm asking is because if you were to call classes, that class has to do very detailed stuff. And when I think of that, I'm thinking of like C, where you go into the memory and you change around, like kind of like the linked list package, where there has to be some sort of like sentinel node that the class has to make, and so on and so forth.
Yeah.
I'm wondering about that.
So interesting question. The first level answer is no, right? If I have a class in Java and I have a class in C++, they really don't play with each other. All things being equal, but most languages have ways to get around that. And so I can use a native keyword, for example, and in my Java code I can start running code that was written in C or C++, and I can say, hey, this is something that was written and compiled in the native language of this CPU, in the native binary of this CPU and this operating system, and I can actually tap into code that was written in a different language. And that gets interesting. It can get quirky. It certainly becomes less portable. But you'll see this with a lot of game development engines, for example. Because, if you're trying to make a game, well, we can, make a window and do some painting and stuff like that. It's not very fast. If you wanted to render 90 frames per second in full color on, a 4K display, you're not going to be able to do that from Java. So you would write some code that, feeds into the GPU calls on your actual hardware, and that would be, a very efficient, very dedicated chunk of code, and we would like to be able to use that from our Java program. And so we would have some parts of our game that were written in Java that called methods that were actually, hooks into this thing that was written in a different language. And so it is possible, but it gets interesting really quickly. But by itself, having a Java class and having a Python class, they don't really interact with each other unless you jump through a lot of hoops.
Is there a way to see the linked list package in code, or is that encrypted?
No. So let's see.
I'm really curious to know how it actually works behind the scenes, kind of thing.
Sure. Let's see what we got here. So all of this stuff is open source. And let me see if I can find this really quickly. So this is purely coincidence. I happen to have the source code for linked list. And so here's the implementation of a linked list in Java. All right. So, comment block in the top with ownership information and so on. Package, it uses something called Java Utility Function Consumer, and this does a lot of the work of a linked list. And so a linked list is really kind of a wrapper around this other class, and we could find the source code for a consumer also, but if we assume that that's known, right? Doubly linked list implementation of list and DQ interfaces, right? And so here's this block of comments in the beginning of the class, right? But it's tagged with /*, and this this is what generates this, right? So W linked list implementation of list and DQ, well, that's what we've got here. W linked list implementation of list and DQ interfaces. So all of this documentation that we've been looking at all quarter is generated from the source code for these different classes. So the linked list class, tons of documentation in the beginning. Here's the declaration of the class. It's generic. It implements some interfaces. Here's the constructor with no arguments. Doesn't do anything. Here's a constructor with some other arguments, and it does some mysterious stuff. It calls the default constructor, and then it adds this collection. So you can construct a linked list with initial elements in it. So that's a different type of constructor, and so on. So let's look for pop. So here's the pop method, and that just calls remove first. And what does remove first do? Well, that's going to be harder to find. Sets f equal to first, and if f is null, it throws an exception. Otherwise, it unlinks that element from the linked list. So this is not what our remove first code looks like in C. In C, we would say, you know, get ready to return the thing the sentinel points to, and have the sentinel point to what the sentinel points to. And it would be a couple of assignment statements. But it looks like the first element of the list is always available in this thing called first. Right? That gives you quick access to it. And that's saved in this element f, which is going to be returned. And there's an unlink first, which I believe actually removes the first element of the list. And unlink first does some gory level stuff. So this is closer to this stuff that's actually, you know, manipulating the list. If next equals null, last equals null, else next.previous equals null. And so this is starting to look more like the linked list that we created in 222. And there's a modification count, which is keeping track of how many changes we made to the list. And there's a size argument, which gets decremented. So when we ask for the size of the list, presumably it's just going to return size. And instead of counting the nodes every time we add, it increments this. Every time we remove, it decrements this. And so that's a way to more efficiently handle the size method. And this whole thing is, you know, 1,200 lines of Java. And a lot of those lines are built on top of other methods in other classes. So this is phenomenally complex, right? But, you know, it's just Java. And you can find this and work through it and so on and so forth. Here's the hash table code. Well, that's 1,400 lines. And it's built on top of other things, but we could go through here and we could figure out exactly how the hash table works. How does it hash a key? How does it decide what the load factor is? And when does it resize the table? And so on and so forth. So you can go online, you can download the source code. It's big, but it can be interesting to look at. Scanners, 2,600 lines. Well, this is a parser. Right, this lets you do things like regular expressions, and so, you know, just the documentation gets pretty complex, and it's got lots of methods that don't seem to do a whole lot, right? And lots of fields, and then lots of gory stuff that you don't really want to have to write yourself. And so this is the stuff that people sometimes try to squeeze in when they don't know how to use the scanner method. The scanner methods, they'll try to parse things by themselves, right? Well, that's what's going on in here. Ultimately, someone needs to decide what is a double precision floating point number. What things are it allowed to have? Is it allowed to have and not have, right? And that's, you know, what you can find inside here. But this is a pretty mind-numbing class. So yeah, that's good stuff to take a look at. All right, any other questions?
No.
Well, I'm going to leave it there. I'll let you out 2.5 minutes early. So finish up PA5, right? Come to office hours if you need help. Finish up PA5, and then next week is week 10. So we've got 2 classes left. Wednesday I'll probably leave just for, you know, doing a quick review of topics and any final questions. Monday I'll either start review or maybe we'll jump into something different. Maybe we'll do a quick run through of Android development, which is another, you know, Java-like, Eclipse-like environment. Or maybe we'll do some C++ or something. I'll figure it out. But
Android is Java or Eclipse-like? I can't.
So Android is used to be Java. Now you can do Android development in Java or Kotlin. Kotlin is similar to Java, but you can do all of Android app development in Java. And Android Studio is similar in Eclipse in the sense of, you know, drag and drop design of GUIs and things like that. It's actually IntelliJ instead of Eclipse, but same basic idea, and the way we paint, the way we link code to events and so on is similar, right? It's peculiar to that environment and that operating system, but the basic things we've been learning with Swing and GUIs and so on translate well to something like Android development. And so it's kind of a fun way to sort of take what we've done and almost for free, you know, be able to spin up some simple applications on a totally different system. So we may play with that. All right, cool. I will say have a great afternoon. Enjoy the day. Take care of yourselves, and I will see everybody next time. Thank you.